Welcome to a lesson with Dr. Powell. Let's take a look at some special angles on the unit circle. So let's take the unit circle and we're going to focus on the first quadrant. Remember, the unit circle has a radius 1. So let's look at a close-up. Okay, starting with an angle of 0, and this is half the way to pi, so it's pi halves. Right here is a fourth of the way to pi, so it's pi fourths. And then we're going to split this up into 3 equal parts. Now, if you split pi halves into 3 equal parts, you get pi 6. So a pi 6 here, and another pi 6, and another pi 6. Because it's a sixth of the way, since it's a third of the way to this, it's a sixth of the way all the way over. And so this would be 2 pi 6, or rather just pi thirds. And notice the pi fourth splits this right down the middle right here. And this angle in between is pi twelfths. Okay, so these are our special angles that we normally think about for some special values of coordinates on the unit circle. So when we're, at least in applications, often we use, at least in a class like this, we often make our applications so that we can focus on some nice angles and know some nice coordinates here to help us out. So it'd be nice on the unit circle, radius 1, to know what the actual coordinates are, xy coordinates are, of each of these points. Okay, now knowing this is as simple as 0, 1, 2, 3, 4. That's as simple as it gets. Oh, how so? Well, what we're going to do to this list is we simply square root each number and then divide by 2. Notice that this list just becomes 0, 1/2, square root of 2 over 2. Another way of writing that is 1 over square root of 2. That's often useful to realize that. Square root of 3 over 2, and simply 1. Now, the x coordinates will follow this order from here: 0, 1/2, square root of 2 over 2, square root of 3 over 2, and 1. The y coordinates followed as well: 0, 1/2, square root of 2 over 2, square root of 3 over 2, and 1. So knowing this order, and knowing that the smaller, for instance, pi thirds gives you a smaller x coordinate, but it gives you the bigger y coordinate. Notice that the smaller x and the bigger y are here symmetric. In fact, in any of these cases, you always get some kind of symmetry in this list. If one coordinate is here, the other coordinate is symmetric across the middle to here. If one coordinate here is here, the other coordinate is here. If one coordinate is here, the other coordinate is symmetric across this list. And so knowing one, you can know the other very nicely by this kind of symmetry going up and down. Okay, now we can use this to think about trig functions. Let's start simply. How do we define what the cosine of an angle is? The cosine of an angle on the unit circle is simply the x coordinate of where this ray right here, or this line segment, ends on the circumference of the circle, on the outside of the circle. So cosine theta would be the x coordinate. Sine theta is the y coordinate. Okay, so we could compute what the cosine of, let's think about the cosine of pi 6. Pi 6 is the smaller angle, which actually is a smaller angle And the smaller angle gives you the bigger x coordinate here before you get to 1, which is square root of 3 over 2 in that list. So this would be square root of 3 over 2. Now by symmetry, we should be able to spot what sine of pi 6 is across that list with symmetry. Let's list it out. 0, 1/2, square root of 2 over 2, square root of 3 over 2, and 1. Since the x coordinate was this, the y coordinate will be that. And that should make sense because we have the smaller angle and we have the smaller y value coming down before you get to 0. So in that way, we can actually compute cosine and sine. Now, if we move to other quadrants, how would that work with angles that go elsewhere? So what if we had, for instance, the sine of 5 pi 6? Well, notice that 5 pi 6 is pi 6th away from pi, right? So we're going to get some symmetry going on from over here. If we know what this coordinate is over here, we should be good. And we know that the y coordinate will be 1/2. The x coordinate will be square root of 3 over 2, as we just discussed. Then over here, by symmetry, we should know exactly what this is. The y coordinate is again 1/2, and the x coordinate is negative square root of 3 over 2, just by this reflection over. So sine of 5 pi 6 will simply be 1/2, and the cosine of 5 pi 6 will be equal to negative root 3 over 2. Thanks for watching.